Hello, tech enthusiasts. Welcome back to Tech Chronicles, your guide to the fascinating world of electrical systems. Today, we're diving into the heart of industrial machinery, three-phase motor starters. These unsung heroes play a crucial role in countless applications, from powering heavy-duty machinery in factories to driving pumps and HVAC systems in commercial buildings. In this edition of Tech Chronicles, we'll demystify the world of three-phase motor starters. We'll break down their importance, delve into the installation process, and equip you with the knowledge to tackle this task with confidence. Whether you're a seasoned electrician or a curious DIY enthusiast, this guide will serve as your roadmap to mastering motor starter installations. Let's get those motors running. Before we jump into the installation process, let's take a moment to grasp the fundamentals of three-phase power. Unlike single-phase power commonly used in residential settings, three-phase power delivers three alternating currents that are out of phase with each other. This results in a more efficient and powerful electrical supply, ideal for running large motors and heavy machinery. Think of it like this. Imagine pushing a heavy object. It's much easier and more effective to have three people pushing in a coordinated manner, each applying force at a slightly different time. The three phases work together to provide a constant and powerful rotational force, making it perfect for driving motors. Directly connecting a large motor to a three-phase power supply would be like slamming a car into gear at full throttle. It would result in a massive surge of current, potentially damaging the motor and the electrical system. By gradually ramping up the voltage and current, motor starters ensure a smooth and controlled start, protecting the motor from damage and extending its lifespan. Now that we've covered the basics of three-phase power and the role of motor starters, let's take a closer look at the essential components that make up these devices. Understanding these components is crucial for a successful installation and for troubleshooting any potential issues that may arise. 1. Contactors. These are the heart of a motor starter. Contactors are essentially electrically controlled switches that establish and interrupt the power supply to the motor. 2. Overload relay. Just like any electrical device, motors can overheat and get damaged if subjected to excessive current for prolonged periods. These clever devices constantly monitor the current flowing through the motor and trip if it exceeds a safe limit, effectively disconnecting the motor from the power supply and preventing damage. 3. Enclosure. All these components are housed within a protective enclosure that shields them from dust, moisture, and other environmental factors. 4. Control circuit. This is the brain of the motor starter, responsible for receiving control signals and activating the contactor accordingly. Understanding the function of each component and how they interact is crucial for a successful motor starter installation. In the next section, we'll delve into the step-by-step installation process, guiding you through each stage with clarity and precision. Before we dive into the nitty-gritty of installing a three-phase motor starter, let's take a moment to emphasize the paramount importance of safety. Working with electricity can be dangerous, and it's crucial to prioritize safety precautions to prevent accidents and ensure your well-being. First and foremost, always disconnect the power supply to the circuit you'll be working on before commencing any electrical work. Double-check the circuit breaker or disconnect switch to ensure the power is completely off. Once the power is disconnected, verify the absence of voltage using a reliable voltage tester. Don't rely solely on visual inspection or assumptions. When working with electrical components, it's essential to wear appropriate personal protective equipment, PPE. This includes safety glasses to protect your eyes from flying debris, insulated gloves to prevent electrical shocks, and flame-resistant clothing to minimize the risk of burns. Finally, never work alone when dealing with electrical systems. Taking the necessary precautions will ensure a smooth and accident-free installation process. Section 5, Step-by-Step Installation Guide. Now that we've covered the safety precautions, let's roll up our sleeves and dive into the step-by-step process of installing a three-phase motor starter. Don't worry if you're new to this. We'll guide you through each stage with clear instructions and helpful tips. Step 1. Mounting the motor starter. Begin by selecting a suitable location for mounting the motor starter enclosure. Choose a location that is easily accessible for maintenance and troubleshooting, while also providing adequate clearance for wiring and connections. Use appropriate mounting hardware to securely fasten the enclosure to a sturdy surface. Step 2. Connecting the power supply. With the enclosure securely mounted, it's time to connect the 3-phase power supply to the motor starter. Carefully strip the insulation from the power supply wires, ensuring you remove only the necessary amount to expose the conductor. Connect the 3-phase wires, typically labeled L1, L2, and L3, to the corresponding terminals on the motor starter's line side. Step 3. Connecting the motor. Next, connect the motor leads to the motor starter's load side. Again, strip the insulation from the motor wires and connect them to the corresponding terminals on the motor starter. Ensure the connections are tight and secure to prevent overheating and potential hazards. Step 4. Wiring the control circuit. This involves connecting the control devices, such as start and stop buttons, to the motor starter's coil and auxiliary contacts. Refer to the wiring diagram provided with your specific motor starter model for accurate connections. Section 6. Troubleshooting common issues. Congratulations! If you followed the previous steps carefully, you've successfully installed your 3-phase motor starter. However, even with the best installations, occasional issues can arise. Let's explore some common troubleshooting tips to help you diagnose and resolve any problems that might pop up. Issue 1. Motor fails to start. If the motor doesn't hum or show any signs of life when you press the start button, start by checking the control circuit. Ensure the start button is properly wired and functioning correctly. Next, verify that the contactor coil is receiving the correct voltage. If the coil is energized but the contactor doesn't close, the contactor itself might be faulty and need replacement. Issue 2. Motor humming but not rotating. If you hear a humming sound from the motor but it doesn't rotate, it could indicate a problem with the motor itself or a mechanical issue. Check the motor shaft for any obstructions or binding. If the shaft rotates freely, the problem might lie within the motor's internal windings, requiring professional repair or replacement. Issue 3. Motor overheating. Overheating can be caused by a variety of factors, including overload, low voltage, or poor ventilation. If the motor feels excessively hot to the touch, start by checking the overload relay. Ensure it's properly calibrated and functioning correctly. If the relay is fine, check the voltage supply to the motor. Just like any other electrical system, 3-phase motor starters require regular maintenance to ensure optimal performance, reliability, and longevity. Neglecting maintenance can lead to premature failures, costly downtime, and potential safety hazards. One of the most crucial maintenance tasks is regular inspection. Periodically inspect the motor starter enclosure for any signs of damage, corrosion, or loose connections. Look for any signs of overheating, such as discoloration or melting on the contacts or wiring. Tighten any loose connections to prevent arcing or overheating. Another important aspect of maintenance is cleaning. Dust, dirt, and debris can accumulate inside the enclosure over time, potentially interfering with the operation of the contactor and other components. Use a vacuum cleaner or compressed air to remove any accumulated debris. Be sure to de-energize the circuit before cleaning to prevent electrical shocks. Lubrication is also essential for the smooth operation of the contactor's moving parts. Consult the manufacturer's recommendations for the appropriate type and frequency of lubrication. While traditional 3-phase motor starters provide reliable control for a wide range of applications, advancements in technology have led to the development of more sophisticated motor control solutions. These advanced systems offer enhanced functionality, efficiency, and control over motor operation. One such advancement is the variable frequency drive, VFD, also known as an adjustable speed drive, ASD. VFDs allow for precise control of motor speed and torque by varying the frequency and voltage supplied to the motor. This enables motors to operate at optimal speeds for specific applications, resulting in significant energy savings and improved process control. Another notable advancement is the soft starter. As the name suggests, soft starters provide a controlled ramp-up of voltage and current during motor starting, reducing mechanical stress on the motor and driven equipment. Congratulations on completing this journey into the world of 3-phase motor starters. You now have a solid understanding of their importance, installation process, and troubleshooting tips. But the learning doesn't stop here. The world of electrical systems is vast and ever-evolving, offering endless opportunities for exploration and discovery. To further deepen your knowledge and stay up to date with the latest advancements, here are some valuable resources. 1. National Electrical Code, NEC. The NEC is the benchmark for safe electrical installations in the United States. Familiarize yourself with the relevant articles pertaining to motor installations and control circuits. 2. Manufacturer websites. Most motor starter manufacturers provide comprehensive documentation, including installation manuals, wiring diagrams, and troubleshooting guides. Visit the websites of reputable manufacturers like Siemens, Allen Bradley, and Schneider Electric for valuable resources. As we conclude this edition of Tech Chronicles, we encourage you to embrace the spirit of continuous learning and exploration in the ever-evolving world of technology. From the intricacies of motor starters to the vast realm of electrical systems, there's always something new to discover and master. Remember, knowledge is power, and by equipping yourself with the right tools and resources, you can confidently tackle any technical challenge that comes your way. So keep that curiosity alive, never stop asking questions, and embrace the exciting journey of technological discovery. We hope this deep dive into three-phase motor starters has been informative and empowering. Until next time, stay curious, stay safe, and keep those motors running smoothly. Listen up, folks. Three-phase motors, workhorses of the industrial world. From factory floors to power plants, these bad boys are the backbone of countless operations. Understanding their installation is not just for electricians, it's about empowerment. It's about knowing your tools, respecting electricity, and taking pride in a job well done. Now, I'm not talking about some fancy theoretical mumbo-jumbo. This is about getting your hands dirty, understanding the nuts and bolts, or should I say wires and terminals, of these motors. We'll delve into power and control circuits, the yin and yang of motor operation. We'll unravel the mysteries of forward and reverse connections. This ain't rocket science, but it does require attention to detail, a healthy dose of respect for electricity, and a willingness to learn. We'll take it step by step, demystifying the process so you can tackle it with confidence. Remember, a well-installed motor is a happy motor, and a happy motor means a productive you. So, grab your tools, put on your thinking caps, and let's dive into the world of three-phase motor installation. Get ready to learn, to build, and to master the art of harnessing electrical power. It's a journey worth taking, and by the end of it, you'll have the knowledge and the confidence to tackle any motor challenge that comes your way. Before we jump headfirst into wiring diagrams, let's get a grip on the basics. Three-phase motors, unlike their single-phase cousins, run on, you guessed it, three phases of alternating current. Imagine three waves of power, perfectly offset, working together to deliver smooth, consistent torque. These phases, often labeled as L1, L2, and L3, are the lifeblood of our motor. They provide the necessary juice to get the rotor spinning. But power without control is like a canoe without a paddle. That's where the control circuit comes in. The control circuit, my friends, is the brain of the operation. It dictates when the motor starts, stops, and even which direction it spins. It's like a conductor leading an orchestra, ensuring each instrument plays its part at the right time. Now, I know this might sound a bit complicated, but bear with me. Once you grasp the fundamental concepts of power and control, the rest will fall into place. It's like building a sturdy cabin. You need a strong foundation before you can even think about raising the walls. Every craftsman knows the importance of having the right tools for the job. Well, installing a three-phase motor is no different. Before we even think about touching those wires, let's gather our arsenal. First off, you'll need a trusty multimeter. This handy gadget will be your best friend throughout the installation process. It allows you to measure voltage, current, and resistance, ensuring everything is wired correctly and humming along as it should. Next up, a good set of screwdrivers is essential. Phillips, flathead, you name it. Make sure they're insulated to protect yourself from those mischievous electrons. And don't forget wire strippers and crimpers for making clean and secure connections. Now let's talk safety gear. Safety glasses are non-negotiable, folks. You only get one pair of eyes, so protect them at all costs. Insulated gloves are also crucial when working with electricity. Remember, safety first, always. Now, before we even think about touching those wires, let's talk about safety. Electricity is a powerful force, and it demands respect. One wrong move can turn a straightforward installation into a shocking experience, and not the good kind. First and foremost, always disconnect the power supply before working on any electrical equipment. Don't just flip the switch. Physically disconnect the power source at the breaker box. Double-check with a multimeter to ensure there's no voltage present. Next, make sure you're working in a well-lit and dry environment. Water and electricity are a recipe for disaster, so keep things dry and avoid working in wet conditions. And remember, never work on electrical equipment alone. Have a buddy nearby who can lend a hand in case of an emergency. Finally, always refer to the manufacturer's instructions for your specific motor. These documents are like the motor's Bible, providing valuable information on wiring diagrams, voltage requirements, and safety precautions. Don't cut corners. Follow the instructions to the letter. Section 5. Power circuit connection, energizing the beast. Alright folks, let's get down to business and start wiring this bad boy up. The power circuit is the heart of the operation, supplying the muscle to get our motor spinning. Remember those three phases, L1, L2 and L3 we talked about earlier? Well, it's time to connect them to the motor's terminals. Typically, you'll find these terminals labeled as T1, T2 and T3 on the motor's connection box. Now pay close attention to the wiring diagram, as the specific configuration might vary depending on the motor's voltage and other factors. Using your trusty wire strippers, carefully strip the insulation off the ends of the power cables, exposing just enough bare wire to make a secure connection. Don't strip too much, as it can lead to shorts and other electrical gremlins. Now connect the power cables to their corresponding terminals on the motor, ensuring a tight and secure fit. Use appropriate-sized wire nuts or crimp connectors to secure the connections and prevent any stray wires from causing mischief. Section 6. Control circuit connection, taking the reins. With the power circuit connected, it's time to move on to the control circuit, the brains of our motor operation. This circuit is responsible for controlling the flow of electricity to the motor, determining when it starts, stops, and even which direction it rotates. The control circuit typically consists of components like contactors, overload relays, and a start-stop button station. Contactors act as electrically controlled switches, while overload relays protect the motor from overheating by interrupting the circuit in case of excessive current draw. Now, the specific wiring of the control circuit can vary depending on the desired functionality and the complexity of the system. However, the basic principle remains the same: to control the flow of electricity to the motor's windings. Refer to the wiring diagram and carefully connect the control circuit components according to the specified configuration. Ensure all connections are secure and properly insulated to prevent any electrical mishaps. Section 7. Forward operation, setting things in motion. With both the power and control circuits wired up, we're getting close to the moment of truth, starting our motor in the forward direction. But before we do, let's double-check all our connections and ensure everything is in order. First, visually inspect all the wiring, ensuring there are no loose connections, frayed wires, or other potential hazards. Next, use your multimeter to check the voltage across the power supply lines and at the motor terminals. Once you're confident everything is wired correctly, it's time to energize the control circuit. With the start button pressed, you should hear the contactor engage, allowing electricity to flow to the motor's windings. If everything goes according to plan, the motor should start smoothly and begin rotating in the forward direction. Observe the motor's operation, listening for any unusual noises or vibrations. Section 8. Reverse operation, shifting gears for backwards motion. Now let's talk about reversing the direction of our motor. This is often necessary in applications where the driven equipment needs to operate in both directions, like conveyor belts or industrial mixers. Reversing the direction of a three-phase motor involves swapping the connections of two of the motor's power phases. This effectively reverses the magnetic field within the motor, causing the rotor to spin in the opposite direction. The specific method for reversing the motor's direction can vary depending on the control circuit configuration. Some systems might use a dedicated reversing contactor, while others might employ a more complex arrangement of relays and switches. Refer to the wiring diagram and carefully follow the instructions for reversing the motor's direction. Once you've made the necessary wiring changes, double-check all connections before energizing the circuit. Section 9. Troubleshooting tips. Navigating common hiccups. Even with the best intentions and a meticulous approach, things can sometimes go awry during motor installation. But don't fret. Troubleshooting is all about using your knowledge and a systematic approach to identify and resolve issues. One common problem is a motor that hums but doesn't start. This could indicate a problem with the power supply, a blown fuse, or a faulty contactor. Check the voltage at the motor terminals and inspect the control circuit components for any signs of damage or malfunction. Another issue you might encounter is a motor that trips the overload relay shortly after starting. This suggests the motor is drawing excessive current, possibly due to an overload condition, a mechanical problem, or incorrect wiring. If you encounter any unusual noises or vibrations during motor operation, it's crucial to investigate the cause immediately. These could be signs of bearing wear, misalignment, or other mechanical issues that require attention. Section 10. Conclusion. Your journey to three-phase motor mastery. Congratulations, folks. You've made it to the end of our whirlwind tour of three-phase motor installation. We've covered a lot of ground, from understanding the basics of power and control circuits to mastering the art of forward and reverse connections. Remember, installing a three-phase motor is not just about connecting wires. It's about understanding the underlying principles, respecting the power of electricity, and taking pride in a job well done. It's about empowering yourself with the knowledge and skills to tackle challenges head-on. Now go forth and put your newfound knowledge into practice. Don't be afraid to get your hands dirty, to experiment, and to learn from your experiences. And remember, the journey doesn't end here. There's always more to discover, more to learn, and more to master in the world of electrical engineering. So, keep that spark of curiosity alive, keep those tools sharp, and keep striving for excellence in everything you do. And who knows, maybe one day, you'll be the one sharing your wisdom and guiding others on their own journey to three-phase motor mastery.